It looks simple, but it's not simple. If I ask you to pause this video and solve it, how many of you can be able to fix this problem? Just look at it. Can you do something about it? Just pause the video right now and do something about it. Okay, what do you think we can do? Firstly, your idea, can drop it in the comment section. But I feel I can solve this like this. At some point, looking at the problem, I can still reduce it. How can I reduce problems like this? Something can go into this, something can go into this, similar thing can go into them. Okay, if I use 2 to reduce this, if 2 reduces this, I will have 4. If it reduces 6, it reduces 9. So let's put it that way. So this 8 divided by 2. The result will give us 4. I don't know if that makes sense to you. Let's go straight to solving this problem. Okay, at this point we have 8x plus 12 to the power of x, 8 to the power of x plus 12 to the power of x. If I bring this across, we have minus 18 to the power of x. This is equal to 0. All right, I'm going to divide the whole of this equation or expression by 18 to the power of x. So I will have here divided by 18 to the power of x, this 18 to the power of x, this divided by 18 to the power of x. Of course, anything divided by this, that will be 0. So let's leave it that way. So at this point, according to indices or fraction, yeah, if you've done solve before, you will know that this expression can still be written as 8 over 18 all to the power of x, because this s can have part in these two expressions. So this can be written like this. It's the same thing. And then 12 divided by 18 all to the power of x is the same thing. Minus 1. This divided by itself is 1, equal to 0. All right. So what is the next point here? If I look into this problem, you will see that if 2 goes into this 8, we'll have 4. We'll have 4, right? And if 2 goes into this particular 18, we have 9. So I have 4 over 9 to the power of x plus, in this case, what can go into the 2 of this equation? If 2 goes here, I will have 6, right? And if 2 goes here, what if you try 3? If 3 goes into, I'm looking for something that looks alike. So let's think of let's think of 3. If 3 and 3 go into 18, that is the first question you ask. Yeah, it can. So 3 goes into 12, that will be 4. Divide 3 goes into 18, that will be 6. All to the power of x minus 1 equal to 0. Again, looking at this problem, simple. I can be able to say at this point that this is the same thing as 2 to the power of 2 will give us 4, and 3 to the power of 2 can produce 9, all to the power of x. Does that make sense to you? Here also, I don't know, you can still cancel, you can reduce here. 2 can go into 4, and if 2 goes into 4, that will be 2 times, and 2 goes into 3, into 6, that will be 3. All this to the power of x minus 1 equal to 0. All right? So look at this expression. This can also be written as 2 over 3 all squared, and we have x already there, so it multiplies the x, right? Plus 2 over 3 all to the power of x minus 1 equal to 0. At this point, you'll be wondering, what is it going to do? What is the next step? Yes, the next step at this point is assumption. We're going to make assumption that let 2 over 3 to the power of x be equal to, what variable can we use? Let's choose k. Okay, that means at this point I will have k squared, because we have 2 over 3x, which is 2 over 3x, and that will turn to k. What is remaining is the 2, which is the square, plus the whole of this will be k minus 1 equal to 0. That forms a quadratic equation. Oh, that is beautiful. And this quadratic equation, we can't factorize this. It doesn't seem factorizable. So at that point, we can apply the formula method. And if we were to apply formula method, then the coefficient of this highest degree of k is 1. A equal to 1. Our B is equal to 1. And our C is minus 1. So let's put that into the equation. The equation states that k equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. I hope you can remember that expression or this equation. This is the formula method of a quadratic equation. Right, how do we substitute this into this formula? It's simple. We have k equal to minus, what is our b? Our b is 1, plus or minus the square root of b squared, that is 1 squared is 1, minus 4 times a. Our a is 1, c is minus 1. So we have 4 times a, 4 times 1 times minus 1. That will give us minus 4 all over 2 times 1. Our a is 1, which is 2. All right, let's take it up again. Where can we use at this point? We can let go of this part so that we use it to solve this problem. All right, so from what we have here, k will be equal to minus 1 plus or minus minus is plus 1 plus 4, that is the square root of 5 all over 2. 5 is not a perfect square, so we can't get the square root of that, and we don't need any decimal number. And then at this point, this expression can be written as minus 1 plus, because of plus of minus or minus 5 over 2, or the value of k could also be minus 1 minus the square root of 5 all over 2. And this is give us a negative value, and that is to say we will not make use of this. Let's go by the positive value. How do I mean by positive value? Because minus 1 plus root 5 is the same thing as root 5 minus 1. So we don't need anyone starting with negative. It will give us what we want. So at this point, our k, recall that our k is this expression. So in place of this k, I will replace it with this expression. So I will have 2 over 3 all to the power of x. The consign is to look for x. So we want to get rid of the k. Equal to minus 1 plus root 5 over 2. At this point, I don't know what to do. So what can we do at this point, my viewer? Tell me. I think we're going to take the logarithms of both sides of the equation. So we'll have here to be the logarithm of 2 over 3 all to the power of x to this same base. To this same base. Is there any need writing it? Yeah. Let me write it so that I will show you what will happen next. To this same base only, equal to the log, do the same thing to the right hand side and left hand side. The logarithm of minus 1 plus root 5 over 2 to the same base of 2 over 3. So if x comes in front of this logarithm, according to power law of logarithm, x will come back, and then log this by this will give us 1. And 1 times x is x. So we have x remaining. X will be equal to, how do we work on this on the calculator? You can't punch this on the calculator. So how do we rearrange it so that we can punch the logarithm of minus 1 plus root 5 over 2 base 2 over 3? It's simple. This is what you need to do. You have to transform this equation. Let's make use of this part. You have to transform this equation to this form. How do we do the transformation? Look at it. It means that x, this x will be equal to, here we have log minus 1 plus root 5 over 2. This will divide by the logarithm of 2 over 3. We call it change of base of logarithm. So at this point, this ordinary should have been the answer, but if you want to further get the value of x, you can say therefore x is equal to, I think we need to employ the use of calculator at this point. Let's do that speedily. While we are doing it, you can just like the video and then turn on the notification bell, subscribe to the channel, and drop a nice comment if you can be able to be fast. in taking the solution of this. All right, so we have here to be the logarithm of -1 plus the square root of 5. Okay, we close the bracket here. Sorry, let's do that fast. We close the bracket, and this we divide by 2. The whole of the expression divides by the logarithm of 2 divided by 3. And what is the result to this problem? The answer is 1.1868, etc. So this is the value of x. Thank you very much for watching. Thank you very much. Subscribe to my channel. Thank you very much. Thank you. Peace.